There are some cases that use substitution that cannot be used. Example of that is integral of x natural logarithm of x. Even if you set x or natural logarithm of x as u, it will never be cancelled out. So that's why we need to use integration by parts.
So this time we will talk about how we get the equation uv minus integral of v du. So we start off with the uv or derivative of uv equals to u times the derivative of v plus v times derivative of u. So we first integrate the whole equation. So our equation will look like this. Integral of duv equals to integral of u dv plus integral of v du. And then we just transpose integral of u dv to the other side. So that will leave us with the equation uv minus integral of v du.
So, Liate was first introduced by Enrique Suge on the early ages of life. L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, E stands for trigonometric, and E stands for exponential function.
This is commonly used in solving integrals by parts. Although this isn't a rule, this just serves as a guide to solve problems in an easier way. This is not accurate or perfect, but you know, it's just commonly used by mathematicians.
So our given example is integral of x squared times e raised to 2x. Then, set values for u, du, dv, and v. Let x squared be u. Then the derivative of x squared is 2x dx. The next step is the e raised to 2x will be our derivative of u. And the integral of e raised to 2x is e raised to 2x over 2. After getting the set of values, substitute it to given formula uv minus integral of v derivative of u. Our given will be x squared times e raised to 2x over 2 minus integral of e raised to 2x over 2 times 2x dx. After substituting, factor out all the constant, then we will get 1/2 times 1/2 x squared times e raised to 2x minus 1/2 integral of e raised to 2x times 2x dx. Since the integral is still a product, we will again do integral by parts. By only including the ones inside the integral. So let 2x be u. The derivative of 2x will be 2 dx. Our dv is e raised to 2x. And our v is still e raised to 2x over 2. After using the integral by parts, substitute again to the formula uv minus integral of v du. Copy 1/2 x squared times e raised to 2x minus 1/2, then write the value for uv minus integral of v du. So it will become 1/2 x squared times e raised to 2x minus 1/2 times bracket 2x times e raised to 2x over 2 times 1 times negative e raised to 2x over 2 minus integral of e raised to 2x over 2 times 2 dx. Factor out again all the constant. So it will become 1/2 times 2 1/2 x squared times e raised to 2x minus 1/2 times x times e raised to 2x minus integral of e raised to 2x dx. The next step is get the integral of e raised to 2x, which is e raised to 2x over 2. After getting the integral, factor out 2 and times it to the negative outside. It will become 1 over 1 half x raised to 2, 1 half x squared times e raised to 2x minus 1 half bracket x times 2 times x times e raised to 2x minus 1 half times e raised to 2x. After factoring, distribute the 1 half to the x times e raised to 2x minus 1 half e raised to 2x. Then we get the final answer, 1 half x squared times e raised to 2x minus 1 half x times e raised to 2x plus 1/4 times e raised to 2x plus c, or factor out e raised to 2x, so we get e raised to 2x times x squared minus x plus 1 half plus c.
Problem will be the integral of ln x over x raised to 5. So we need to get the u, du, dv, and d values. For us to get the u, du, dv, and d values, we're going to use the Layate order. Since ln x is logarithmic, it will be used first, hence making it our u value. To get du, we are going to get the derivative of ln x, which is 1 over x. Next is the dv. As we can see, the only other term left in the problem is x raised to 5. X raised to 5 is exponential, thus we didn't use it for our u value. We set x raised to 5 as our dv, and to get the d value, we're going to get the integral or antiderivative of x raised to 5. And to get that, we're going to add 1 to the exponent, which will make it x raised to 6. And we're going to copy the exponent and put it to our denominator. So next, we are going to substitute the following values in accordance to the equation uv minus the integral of v du. So our u, which is ln x, and v, which is x raised to 6, minus the integral of v, x raised to 6, and du, 1 over x. So the next step is to factor out the constant. As we can see, x raised to 6 over 6 has a constant on it, which is 1 over 6. So it will be ln x times x raised to 6 over 6 minus 1/6, and the integral of x raised to 6 times 1 over x. As we can see, x raised to 6 and x can be cancelled out. Hence, we can cancel out 1 over x, and then x raised to 6 will become x raised to 5. So next is we are going to get the integral of x raised to 5. And to get that, we're going to once again add 1 to the exponent and copy the new exponent to become our new denominator. So it will become ln x times x raised to 6 over 6 minus 1/6 times x raised to 6 over 6. And we are going to multiply the two denominators, which are the 6 from 1/6 and 6 from x raised to 6, which will make it x raised to 6 over 36. So our final answer will be ln x raised to 6 over 6 minus x raised to 6 over 36 plus c. We can also once again factor out the constant from x raised to 6 over 36, which will make it ln x times x raised to 6 over 6 minus 1 over 36 times x raised to 6 plus c. That will be the final answer for this problem.
So let's have some more examples. So we have here integral of x cubed cos x. So like any other problem in this topic, we identify u and v using Layate. So u is equal to x cubed and du is equal to 3x squared dx. dv is equal to cos x dx, and v is equal to sin x. So next is we substitute the values to the equation uv minus v du, minus integral of v du and the equation will look like this. So x cubed sin x minus integral of sin x 3x squared dx. Since we still have a product function inside the equation, we still have to integrate it until we can factor out one term. So the u this time is 3x squared, the du is equal to 6x dx, the dv is sin x dx, and the v is negative cos x. So the equation will be x cubed sine x minus times negative 3x squared cos x minus integration of negative cos x 6x dx. Again, we identify u, and so the u this time is 6x, du is 6dx. The dv is negative cos x dx, and the v is negative sine x. And then we have x cubed sine x minus times negative 3x squared cos x minus times negative 6 sine x minus the integration of negative sine x 6 dx. Now we can finally factor out one term, which is 6, and then integrate the negative sine x. So this time the equation is x cubed sine x times negative 3x squared cos x minus times negative 6x sine x minus times 6 times cos x. So when distributing the signs, we start in the innermost part of the equation. So our final equation will look like this: x cubed sine x plus 3x squared cos x minus 6x sine x minus 6 cos x plus c.
We have our problem, the integral of x squared sine x dx. In this problem, we have two terms at the expense of products and multiplication, so we can't integrate this problem immediately. We will need to apply integration by parts. So integration by parts has a formula, which is u dv equals ub minus the integral of v du. So we need to identify which of our two terms is our u and our dv, so we can get its derivative and antiderivative or integral, respectively. In finding our u, we have this thing called liate, which stands for logarithmic, inverse, algebraic, trigonometric, and exponential functions. We use this by when finding your u, whichever of your terms category comes first will serve as our u. You don't need to apply liate always, like I said. It just serves as a guide of some sort. So we're gonna split our problem with its two terms to categorize. We have an algebraic x squared and a trigonometric sine x. So since algebraic comes before trigonometric, x squared is our u and sine x, which is our x's, will be our dv. The next thing we have to do is find the derivative of u, or our du, and the antiderivative or integral of dv, which is our v. For us to be able to substitute our formula completely, the derivative of x squared is 2x, and the antiderivative of sine x is negative cosine x. After that, we're just gonna substitute all of that we've got into our formula structure. So now we have x squared times negative cosine x minus the integral of negative cosine x times 2x dx. Now, we have this rule called the constant multiple rule, in which if we apply it in our problem, it will just basically be factoring out constant numbers inside the integration sign. So let's just go ahead and apply it. We have x squared times negative cosine x plus, because we factored out the negative sign, which also stands like a negative 1 from the inside, so plus the integral of cosine x times 2x dx. Now, we have encountered another problem that can't be integrated directly. This is because of our two terms, cosine x and 2x. So, we need to break it down once again, which will push us to apply udv equals uv minus the integral of v du once again. So, basically, just reviewing the steps that we did before. By the way, this is called double integration, since we applied integration by parts twice. Now, we have 2x as our u, since it's algebraic, and cosine x is our dv. The derivative of 2x is 2, and the integral of cosine x is sine x. Substituting it into our formula, we're just gonna plug it to our previous equation. We have x squared times negative cos x plus or times 2x times sine x minus the integral of sine x times 2 dx. So we're gonna bring 2 before sine x and then factor it out. We have x squared times negative cos x plus or multiplied to 2x times sine x minus 2 integral of sine x. So the integral of sine x is negative cosine x, which will give us x squared times negative cosine x plus or times 2x times sine x minus 2 negative cosine x. So simplifying, we have bring out the negative of cosine x right before x squared, which will make it negative. 2x sine x will stay the same. We're gonna bring out the negative of cosine x, multiplying it with the negative sign of negative 2, which will make it positive. So let me just write down our final answer. which is negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. So there you have it. We're done and solved our problem.
So we're asked to find the integral of x squared ln for x. So firstly, we get the values of u, du, v, and dv. And after getting the values, we implement the formula of uv minus the integral of v du. And after we get the formula, we substitute it into the given formula. And then after substituting it, we need to factor out 1/3 out of the x cubed. And after that, we could cancel x here so that it is remained 1. And after that, we get the integral of x squared so that it became x cubed all over 3. And after that, we factored out again 1/3. And after that, we applied multiplication of 1/3 times 1/3. The result is negative 1 over 9. And overall, the result is 1 over 3 ln 4x times x cubed minus 1 over 9 times x cubed plus c. Always remember to put c on the final equation. That's all, thank you.
The last example would be integral of x squared e raised to x dx from 0 to 1, which is a definite integral. So, our process would be a little different at the end. First, we would integrate x squared e raised to x and disregard first the boundaries. Then, we would set the values for u, derivative of u, v, and derivative of v, which are respectively x squared, 2x dx, e raised to x dx, and e raised to x. We would now substitute the values at the equation uv minus integral of v for u. Notice that in the integral, it is still a product, so we would again integrate by parts. Set again the values, and substitute the formula only at the integral part. Then copy the first terms. The values are u is equals to 2x, d is equals to 2dx, dv is equals to e raised to x dx, and v is equals to e raised to x. So, our formula now would be x squared times e raised to x minus 2x e raised to x minus integral of e raised to x to x to x. To avoid confusion, distribute first the negative sign to the substituted values. Then, factor out constant in the integral, which would lead to 2 raised to integral of e raised to x. The integral of e raised to x is equal to e raised to x. So, the final answer would be x raised to e raised to 2x minus 2x e raised to 2x plus 2 raised to 2 times e raised to 2x plus c. Now, going back to the values, we would subtract the values of substituted lower boundary to the substituted upper boundary. Substitute 1, the upper boundary, then subtract it to the 1 substituted to 0, the lower boundary. It would be 1 raised to 2 e raised to 1 minus 2 times 1 e raised to 1 plus 2 times e raised to 1 minus 0 raised to 2 e raised to 0 minus 2 times 0 e raised to 0 plus 2 times e raised to 0.
Automatically, 0 raised to 2 e raised to 0 and negative 2 times 0 e raised to 0 will be cancelled out, leaving only positive 2 e raised to 0, which would be negative if the negative sign is distributed. When simplified, it would be e minus 2e plus 2e minus 2. Cancel out the 2e's, so it would be e minus 2, which would be the final answer.